Yes, the recording has started, and you can see there are a few questions starting from Mr. Tamal Sarkar, but Tamal Sarkar already told that he has got his answer. At 8:02, Manas Chakraborty asked the question. Will you take the question yourself, or should I read it for you?
Okay, let me read it out.
Okay, okay, thank you, sir. Thank you,
Okay.
sir.
How can we relate to keep a very low frequency to get accurate time from the physics
No, sir,
perspective?
you scroll a bit up. Manas Chakraborty question starts from 8:02. At, at
Okay. Does
8,
the time same in the moving and accelerating frame of reference? What he says that he has got all the answer.
yes, Dr. Tamal Sarkar, he has got all the answers. So for Manas Chakraborty.
Okay. So Manas Chakravarti says, how can we relate to keep very low frequency to get accurate time from the physics perspective? Well, accuracy time and the frequency, I cannot say it is very much related, as I told you, that frequency, if it is accurate, time is accurate, not the what frequency it is. So, if it is a very high frequency, then it will be more accurate, or it is low frequency, low accurate. That doesn't have correlation. Correlation is that how frequency is accurate, whether low or high. That is important. So, so you cannot get a accurate time from the low frequency unless it is not accurate. Am I clear, Manas Chakravarti?
Sir, I want to know that, sir, you told your discussion that we have to get an accurate time. We have to set the, we have to minimize the frequency as possible as we can. And
Minimize means minimize,
uh,
not minimize frequency, minimize the error, not minimize the value of the frequency. Minimize the error in the frequency. Suppose if I call it 1 megahertz, it should be exactly 1 megahertz. If you say 1 hertz, for example, 1 second pulse is a 1 hertz pulse. So 1 hertz, let it be 1 hertz, I don't mind. It is a low frequency like 1 hertz. But it should be exactly 1 hertz. Otherwise, it will not be correct. 10 megahertz, it should be exactly 10 megahertz. Otherwise, time will not be correct. Because the
okay,
relation is that I have shown that when there is a slight frequency offset, the time goes linearly, either
yes, sir.
slow or fast.
Yes, sir. Yes, sir. From
So
this.
accuracy is important, not the frequency, absolute value of the frequency. It is low or high.
Okay, sir. Okay, sir.
So now the another thing is that the meaning of the integration time from the microsynthesizer in the physics package, is it the comparison between the time? Now, may I know who is Manas Chakravarti? Is it you are working on the physics package of the atomic clock?
No, sir. I am a sir, student, sir, of
Okay,
Burdwan
okay.
University.
Let me tell you
Sir, this
that
terminology you used, interrogation, sir, it is absolutely new to me. That is
okay.
why I asked
Well,
you.
let me tell you the integration time is that you see that I as because you have not studied the atomic clock structure. Let me
No, sir. No, sir.
let me explain you in a very short time in a little crude way that you see that when you are looking at the atomic clock physics package and you are comparing with a, a frequency, you are irradiating a frequency with an atom will have a transition and it will maximize the frequency when the frequency exactly matches. Now, thing is that important thing is that when you are radiating a frequency, it is actually you are looking at the atomic atom, how long you are at, because atom is also running fast. It's not a stationary thing. It is also moving here and there. So you'll have to find that how long you can interrogate the atom, particular atom you are looking at, and that will give an accuracy. That is why the cesium fountain, when it is cold, moment it is cold, that is in the micromilli Kelvin, then the cesium atom becomes almost stationary. So you have a larger time to interrogate it. The longer you will be interrogate, so less will be the signal to noise ratio. Signal ratio will improve, and you will get a better accuracy. So if I would to explain little more, then I'll have to go to a little more detail. I don't know. If I get a time to talk to you little later, then I can explain how it works. But
Sir,
if
sir,
uh,
on the coming week, sir, you came to our university, sir. Then I met you and
okay, okay,
okay,
okay, then
my
I'll
question.
explain. But the
Okay, sir.
important thing is that how long you are looking at the atomic atom. That is the integration time. Longer you'll be able to see the atom, better will be your accuracy.
Sir, another question, sir, that is you tell about in a short duration that in PPP technique, sir, the all the errors that you tell that can be reduced to such a extent, sir. I know little about it on the coming week, sir.
Okay,
On it.
okay, okay. You are in Burdwan University.
Yes, sir. Yes, sir. I am an sir. I'm a
Good.
MTech student, sir, in this university.
Oh, then you have the whole group of GPS in your university. They know all these things very well. You can always interact with them and get to know all these things.
Yes, sir. Yes, sir. But I, sir, first get an opportunity to coming across
Okay,
the GNSS.
okay, okay, okay. So even in Monday, I can next week I
Yes, sir.
can discuss with you.
Yes, sir. Yes, sir.
Okay.
Thank you, sir.
So and Pritam Majumdar, you have given a question that how an atomic clock was used to prove that the higher you live up there, faster you age. Well, age about the aging, that is a biological system. I cannot say much, but only what I can comment on it that Einstein has already proved it, and it has been proved later by many other experiments that when you are go above the mountain and then the clock more it reaches near the earth, according to relativity theory, the time slows up. So that means if you go above the mountain, it goes faster and it will not that is the effect. And how much it will have a effect on the age, it is very difficult to say. But the time will change. And the next question is Tamal Sarkar, you already got the answer. Manas Chakravarti, do you have another question?
Yes, sir. I have another question, sir. You have said that dual by use of dual frequency receiver, we can cancel out the most of the error. Sir, my question is simple. So that instead of dual frequency receiver, if we use triple or quadruple frequency receiver, sir, it is possible to get the errors to more such extent, or sir, system complexity is in this.
Well, it's a very interesting question. You see that you must understand how dual frequency improves the accuracy. That is the first thing. Then your question comes of the triple or four frequency will improve. You see that if you, I do not know whether I could get a time to properly explain. If you use dual frequency, then ionospheric error only get reduced greatly, not all the other factors. It is only the ionospheric error. The ionospheric error will get improved by a great extent, and other factor will for all any other reasons. For example, it is IGS network helps you to improve the time, improve the error. There are carrier phase will improve the multipath error, and these are the all things. So it is not the dual frequency helping you to correct all the. It is only dual frequency only help you in correcting the ionospheric error. And I doubt whether triple frequency. Firstly, if you get a triple frequency, it is a receiver complexity will increase a lot. And thirdly, that you may not get the fourth frequency at all. Uh, and third frequency even will not improve any further because dual frequency takes care of the ionospheric error. So the your question of getting triple or fifth is a very imaginary question. So dual frequency will definitely improve. And adding frequency, either it will complexity, but of no use in improving the frequency.
Okay, sir.
Yes.
Thank you, sir.
Okay. And Arpita who doesn't have any question. And any
Uh,
other question?
yes. Any other question you can?
Okay.
Yes,
Good evening,
Ankita.
sir.
Yeah, good
Sir,
evening.
yeah, sir, actually, we are using atomic clocks in NAVIC systems also. But most of the atomic clocks are malfunction. Means out of seven, four satellites have the issue with malfunction of atomic clocks currently. So my question is, sir, the outer electromagnetic field, Earth's electromagnetic, will it will be the reason for the malfunction of atomic clocks? Because atomic clocks were affected by gravitational fields and electromagnetic fields. And if these are the reason, then why we are using atomic clocks? Because it will cost a lot. And are there other possibility? That is my
Okay.
question.
The question is, I would like to answer this way. The scientists had to wait a long for getting a most accurate clock for the application in the navigation. Because navigation through satellite, if you would like to increase the accuracy, first what you need a very good accurate clock. And now available base clock atomic clock. There is no other better clock than atomic clock. And there might be a failure always. In not only in atomic clock, there may be failure in the payload's other system. So that happens. That is why the redundant system is there. So you cannot think of any NAVIC system, not only NAVIC, but any satellite system without an atomic clock. Now the failure of the atomic clock because of the electromagnetic signal and all this thing, pressure and all this thing, is housed in a such a tight chamber, shielded by the magnetic field, shielded from electromagnetic field, shielded from temperature variation. So that sort of design has been barely successful. So the atomic clock doesn't malfunction so easily. There may be still failure in all the system. But even in the very deep space exploration, this sort of atomic clock is being used. And I have shown one or two figures that where a specially designed atomic clock is being used before launching in the satellite. And there is no way out at present to go for a navigation system without atomic clock.
Yes, sir. Sir,
Uh,
atomic clocks are
Sir,
nothing but
okay, just a minute. Can I add some more thing to it, if you permit, sir?
Yes.
Okay. So, Ankita, you can see that other systems, if you look into the sky now, there are totally more than 135 satellite navigation satellites are there from all constellation, GNSS and RNSS, and all of them use atomic clocks. So, if you look into the history, so GPS came after a trial system of transit, and also GLONASS came after a trial system of what is called the triclone triscada. So there are many background works. Even in case of Galileo also, in orbit validation, IOV satellites were first put into orbit, and after that FOC, that is full operational capability satellites, were put into the orbit. So basically, you can see that there are first trial type of satellites, and after that, learning from that, the subsequent satellites which were put into the orbit, they were developed, and the system was very much successful. So what we picked up during discussion with ISRO people, that obviously there were certain design flaws, and some more testing were required like that. So we can expect that in future this problem will be taken care of in the NAVIC system. But obviously, as Dr. Banerjee, the best person to answer, who has answered that there is no way out, that I have done the atomic clocks. You must use atomic clocks. Okay, please, Ankita, continue. I disrupted you.
Yeah. So my one more question is atomic clocks and quantum clocks are similar or
Oh, quantum clock has not yet been mechanized yet now, but principle to a great extent, rather principle is anyway, atomic clock is also a quantum mechanics, and quantum clock has not yet been implemented. People may think about it later when it will come into the practice, that what is the status of it and how difficult it is to design and all these things. It's only coming up things in the physics.
thank you, sir.
So actually, Ankita works for the timing section of ITR integrated test range. So she needs quite solid background, and we'll be meeting her during the offline session. And obviously, Ankita will get a lot of chance to interact with Dr. Banerjee and other experts. So it is very good for you, I think. So if there is any more question. If not, so on behalf of all of us here, all the participants and the organizers, we convey our sincere thanks and gratitude to Dr. Banerjee for his very in-depth speech, starting from scratch to the latest in time transfer and time maintenance technology, and the link between the timing and the GNSS. What, of course, whenever we talk about the GNSS system, we talk about PVT or PNT, and the T stands for time. So it's an integral part of GNSS. So thank you very much, sir. Thank you very much, and we'll be eagerly waiting to meet you next Monday. So thank you very much. And with that, we close today's session. Tomorrow, once again, it will be as usual.